He has a background in online database design and management. PlantID goes back to a time when when Bruce came to we used to have a fall potluck, and he came about 8 or so years ago with this idea for an internet program that could be used to identify native plants and that could produce photo illustrated plant lists. It seemed like a good idea. And at that point, PlantID was born. The first plant photos in PlantID were the lifetime collection of Marin native plant photos taken by Bill and Wilma Follett, over 5,000 photos. Bruce is now up to over 130,000 photos. The Grass ID program is something that is unique to Bruce, and it's his latest innovation. I personally am looking forward to this because I've taken several grass courses and still have difficulty identifying grasses. I was up at Rock Springs over the weekend, and I have to confess, did a blank on most of the grasses I saw up there. And Bruce has been very creative in finding ways to use photos and descriptions and locations to ID plants without extensive use of keys. So I am really looking forward, Bruce, to your talk on how we can identify grasses.
Thank you. Are you ready for me to start?
Yes, yes, please do.
Yeah, Dave, I see 11 people in the waiting room.
Okay.
Okay. So do you all see a slide that says identifying grasses for novice enthusiasts?
I do.
Great. Here we go. Grasses have a reputation for being hard to learn about. Grass experts worked very hard to master the subtleties of the Jepson key for grasses and to recognize all the grasses they could find in the field. But you don't need to study dense texts and learn lots of terminology in order to have fun with grasses. PlantID.net provides a different approach designed to give novices a starting point from which to learn about grasses. I'll show you how it works tonight. Traditional approaches to grasses require a lot of study. There's an extensive vocabulary you need to learn. The Jepson key talks about hard to see parts and describes measurements in millimeters. It refers to structures you can only see in a microscope. And there are hundreds of species. CalFlora lists over 1,000 taxa in the grass, sedge, and rush families. We'll avoid most of these difficulties by taking a novice approach to grasses. We'll focus on grasses from one location at a time, simplifying the identification process. Our searches and comparisons will be based on obvious features you can observe in the field. Our goal is to make it easy for you to start observing and learning about California grasses so you can have fun with them. That doesn't mean grasses are easy. There's a ton to learn. PlantID simply provides a path to make it easy for you to start learning about them. Before we focus on how to use PlantID to identify and learn about grasses, I'll show you a 6-minute video that introduces how the PlantID website works. We'll build on that when we get into grasses. Then I'll introduce you to 4 grass-specific terms and 4 types of grasses that we'll use in our simplified PlantID searches. With that common understanding, I'll demonstrate the PlantID approach to identifying and learning about grasses. After a brief summary, we'll be done. I'm hoping you'll see enough tonight to whet your interest in using PlantID to learn more about grasses on your own. Please do ask questions anytime through the chat, and I'll stop from time to time to address them. So now I'm going to start by showing you the introduction to PlantID. This takes about 6 minutes, and then we'll all be on the same page with this basic tool.
Welcome to PlantID.net. I'm Bruce Homer-Smith, and I've created the PlantID website to make it fun to identify and learn about California plants found in the wild. Here's the PlantID homepage. It offers several ways to identify a plant. First, we have a generic search. You can enter anything you know about a plant: its location, plant type, flower shape, color, leaf arrangement, whether it has berries or catkins, what it looks like, such as clover or dandelion, and so forth. You can also search by common or scientific name and whether it's native, rare, or invasive. When you've entered all of your descriptions, click Search to get an illustrated plant list of possible plants. A second ID tool on the homepage starts with your location. PlantID has plant lists for over 500 parks in California. Pick your location to get an illustrated plant list of just the plants at that location. A third way to get started is to choose a plant guide written by an author on a specific topic. For instance, Marin dandelions, or 12 easy grasses, or common muirwoods plants. Whether you start with a generic search, a local plant list, or plant guide, you'll end up at an illustrated plant list. Every illustrated plant list looks like this one, with a title and introduction, an illustrated list of plants, and several tools on the left to help you focus on the plant or plants you're interested in. This Muir Woods plant list was assembled by Elliot Gunnarsson, a naturalist at Muir Woods. It shows the trees, shrubs, flowers, ferns, and grasses you're likely to notice when you visit Muir Woods. Let's choose shrubs as our plant type to focus on. You can view your list several ways. This list is one line per plant with a description and 3 pictures. But you can change it to a photo gallery with 1 picture per plant. That lets you see more plants at once. You can change the sort of your list, for instance, to scientific name. You can turn your list into a report with Report View. We'll run a report with a gallery layout. This report is a PDF, so you can email or print it. Now we'll create a report in text format. We'll sort this report by plant family. This is a handy format to take into the field. Back at the plant list, you can train your eyes to identify the plants on this list by Take the Quiz. You'll get pictures of a random plant from the list with no identification. You can scroll through it to see other photos of that plant. When you're ready, click Show Me the Answer to see the plant page with names and descriptions of your mystery plant. You can turn the quiz into a game with friends by seeing who can correctly identify a plant first. Now we'll focus on learning about a plant. Here we are in the illustrated plant list. You can click any plant name to learn about it. PlantID.net has a plant page for every California wild plant. It shows pictures and descriptions, a range map, links to other learning resources, and a photo gallery. The photo gallery lets you examine different plant parts and life phases. Click any picture to see it full size. Let's dig down deeper to learn about one of the iconic plants at Muir Woods, the coast redwood. We'll bring up the plant page and choose Photo Essay. This photo essay is 18 pages long, which may seem like more than you want, but you'll find it's very easy to learn from. Each page has a large picture and a short description. We'll look at a couple of the pages. Coast redwoods are the tallest living things on Earth, frequently growing over 200 feet tall. Coast redwoods do best in cool, rainy, foggy valleys in the foothills near the northern California coast. They can receive up to 30% of their water from fog. Needles have 2 shapes. The most common is flat. A second kind of needle has an awl-like shape. These needles form on fast-growing branches. Those in the sun or near the top of the tree. I'll scroll through a couple pages here. This coast redwood is at the edge of a road cut, so it has grown a buttress at the base of its trunk that helps it stay upright. When a root system is stressed, as it is here, it sends out new shoots. At the bottom of this photo, you can see a spherical burl that's sending out several shoots that will seek ground to grow. The next couple pages talk about male and female cones on the redwood. The final page shows a range map and outside references where you can learn more. The Jepson video is a great source for learning more. Back on the home page, let's look at the bottom, Featured Plants. These plants change every time the home page comes up, and each is an invitation for you to read a photo essay about that particular plant. Click a featured plant to bring up its photo essay. I think you'll have fun looking through these big pictures and short captions, and I bet you'll learn something new each time you do. To review, PlantID offers several ways to identify a plant. Once you find your plant, you can learn about it by clicking its name. Photo essays provide additional in-depth information that's fun to read. PlantID.net works well on your phone, tablet, or home computer as long as you have internet access. Have fun with it.
Okay, now we're going to get into Grasses terminology. So you've got a basic idea of how PlantID works. We're going to use all those features, but in a more advanced way tonight to learn about grasses. Grass patterns. The spikelet. The spikelet is the single defining characteristic of all plants in the grass family. Pine trees have pine cones. Asters have composite flowers. Willows have catkins. And every member of the grass family has spikelets. No other plant has this structure. A spikelet is how grass reproduction is organized. A spikelet has two glooms at the base, followed by a series of one-to-many florets. So here you can see, this is a diagram of a spikelet with some glooms at the base and then one-to-many florets stacked up above it. Each grass species organizes its spikelets differently. Small fescue has long glooms that hide the florets. That's the picture here. California brome has short glooms that reveal 5 to 10 florets in a woven pattern. When identifying a grass, our first job will be to find and inspect the spikelets. Awns are the pointy things that you see on spikelets. Awns are extensions of veins, bristles that extend beyond the margin of glooms or florets. Awns are a great identifying characteristic, and we'll talk about them a lot. Awns can come just from the glooms, just from the florets, from both, or be missing entirely. Awns can be short or long. They can be straight, curved inward or outward. They can bend once or bend twice or be twisted. They can emerge from the tip of the bract or the middle. Inflorescence types. There's two ways that these spikelets are attached to the grass. These two patterns are what we're calling inflorescence types. Spikelets are arranged at the top of a grass. This area, everything above the leaves, is called the inflorescence. Just as a spikelet appearance varies between species, the inflorescence pattern, how the spikelets are arranged, also varies. When spikelets are attached directly to the stem, we call it a spike-like inflorescence. So here we see dozens of spikelets all connected to a branch, to a stem directly. When spikelets connect to a stem on branches, we call it a branched inflorescence. So here are the spikelets, and here are the branches going to the stem. This is often an easy distinction to make when grasses are mature, so PlantID uses it in its search key. Grass inflorescences often open up at maturity though, so if you're not sure, for instance, if your grass is still maturing, then you would leave this search out. Here's another easy to determine characteristic, grass type. We'll recognize 4 types, 2 true grass types plus rushes and sedges. True grasses have spikelets. They can be either bunch grasses or single stem grasses. They differ in how the shoots or stems are generated. All grasses have roots below the ground and stems above. Here's a diagram of that. The stems of bunch grasses all grow from the same root crown, season after season, old stems re-emerging from the root ball and new stems, called tillers, growing from the same root crown. Single stem grasses work differently. Annual plants grow fresh from seed every year, and perennials, grasses living more than one season, form colonies by growing new stems from stolons and rhizomes that grow sideways from the parent plant. These grasses don't form a clump, but spread out thinly in colonies across the ground. Actually, it can be thinly or thickly. So here's an example of a single stem grass. The lawn grasses are single stem grasses. And then here's an example of a bunch grass where all of the stems are growing from a single root crown. Two other grass types are rushes and sedges. They're not true grasses because they don't have spikelets, but they look like grasses, so we include them in our grass searches. Rushes are round with round stems and tiny 6-part flowers. If you see a grass-like plant with clusters of brown, tiny 6-part flowers on the side, you've got a rush. Sedges have edges, generally with stems that are triangular in cross-section. Their reproductive parts generally hide under the clusters of scales in a variety of patterns. So we have 4 easy to distinguish grass types: bunch grasses, single stem grasses, rushes, and sedges. PlantID uses these obvious characteristics that we've just talked about to help you define the grass search. So the words that I've introduced are the only words you need in order to do PlantID grass searches. You search on grass type, on the typical height, the inflorescence type, either spikelet or branched, and whether or not it has awns. Once you run a search against grasses, PlantID shows you the results in a table, as shown here. The table shows you facts and measurements of grass parts. You can sort on any type of information by clicking on its column header. So for instance, I could click on annual, and I would get all the annuals lined up before the perennials. Other columns are grass type, which could be bunch, single stem, rush, or sedge, typical height, inflorescence type, branch or spike-like, inflorescence length, the height, grass height above the leaves, awn length, florets per spikelet, and native status. So at this point, I'd like to take a quick stop and see if anybody has questions about these terms, because once we have these terms under our belt, the next thing will be to use them in a demonstration of PlantID. So Dave, do you have any questions in the chat?
No questions in the chat, Bruce.
Okay. All right. So now you should be looking at the homepage of plantid.net. And you will always find on the homepage a box under plant guides called plant searches, and grass searches rather. And that's what leads you into this new feature of plantid.net. So we'll click grass searches. Grass searches always happen in a local list. And this is to make it, it's our first step to make it easy to get down to a short list of grasses. So tonight we're going to work on grasses at Ring Mountain. And if I simply search on the grasses of Ring Mountain, I will get a result list that shows me that there are 56 grasses on Ring Mountain. And these are the grasses that are listed in the Marin website for Ring Mountain. So it's based on, this is a perfect example of how PlantID is based on the hard work of hundreds of people. They've all made contributions like you have. And then I can build off of that with this other database information. So let's go back to searches. And we'll start by doing a search of a bunch grass of average height, branched inflorescence, and with awns. And now we'll do a search. And we'll see that there are 12 possible grasses. As you remember, you can click on the column header to organize your 12 grasses in any of these criteria. So I clicked on native status, and you'll see that almost all bunch grasses on Ring Mountain are native, but the two are invasive, the reed fescue and the velvet grass. If I click on awns, then we'll see that some of these grasses have very short awns and others have long ones. The ones that have the longest are the needle grasses. So for instance, if I look at the purple needle grass, I'll see purple needle grass has an open inflorescence and long awns. It has only one floret per spikelet. Spikelets are purplish. Awns are needle-like and about the size as long as your pinky, 1.5 to 4 inches. Awns bend twice when they're mature. The weight of the spikelets and the length of their awns causes the grass to bend at the top and wave in the wind. So this is a typical pattern here. We did a search, we got a result, and then we started looking at a specific plant. In addition to compare grasses, we have all the regular ways of displaying results. So remember in the demo, we have the illustrated plant list, which is 1 line per plant, showing pictures and captions and descriptions. Another way to see your grass results is in a gallery, which is particularly nice when you have a short list. We only have 12 grasses, so we can actually see all 12 grasses right here, and we can visually compare them. Let's take a different search. This time we'll go back to the home page and say grass searches and Ring Mountain. And we'll say single stem grass. So those are the grasses that are not bunch grasses, where every single stem grows from either its own seed or from a rhizome. If we look at this native status, we'll see a very different pattern. A lot of invasives and also non-natives, and only a few natives that are in the single stem group, which kind of matches a lot of our opinions, which is that the bunch grasses tend to be natives and the single stem grasses tend to be non-natives. If we look at the annual status, we'll see that some of these are perennial, these single stems, but a whole lot of them are annuals, growing fresh from seed every year. I'm going to add some more criteria to my search. So I've got a single stem grass, and this time I'm going to say it has a spike-like inflorescence with no awns. And I get a choice of 4. And you notice that one of these says that it has awns, which is weird because our search was single stem grass, spike-like inflorescence, no awns. And the reason is that ryegrass sometimes has awns and sometimes doesn't. So PlantID will always include a plant if it would match the criteria sometimes. So if you're borderline on a particular criteria, then it will include it. So let's look at these by gallery. And you notice here that these grasses look pretty different. The Italian ryegrass, for instance, it is a spike-like inflorescence because there are no branches. These spikelets are coming right down to the stem, and yet they're not tight together like the June grass and the Harding grass. So the Italian ryegrass has a real look to it. If you were able to do this search and then you came to this page, you'd know what you have. So if we go back and think about what's happened in the search, we did a specific location, and then we put in the criteria of what we knew. And now we have this third layer where we can compare grasses either in a table or visually to come up with our identification. Over here on the cattail has 2 spikes, male flowers on top, female below. The dense spikes are separated by a couple of inches. So a lot of these grasses look quite a bit different. Let's go to searching for rushes at grass at Ring Mountain. So this time I'll click on rush and click search. Notice that all the rushes on Ring Mountain are natives. They don't have awns. And all of them are perennials except for the toad rush. And if we look at a picture of the toad rush, we'll see why. Here's the toad rush, a little tiny thing with just 4 inches tall. And it grows from seed every year. All the other ones continue to grow over many seasons. If I go to more searches, I can change my search from rush to sedge and do a search. And I'll see that there are all native, there are 5 sedges. 4 of them are in the genus Carex, and then 1 in cypress, the tall flat sedge. So we haven't spent much time on doing the searches, but we're done with me showing you how to do searches. It's very simple. From the home page, you specify grass search, you say which location, and then you enter whatever criteria match the grass you're interested in, and you'll get to this results environment. So my next step is the more involved step of how to learn about these grasses once you have identified them. But before I do that, let me ask one more time. Does anybody have a question about searching for grasses using PlantID?
Yeah, there are some questions, Bruce. Barbara McCord says, I've been in plant classes where the teacher says sedges don't always have edges and rushes aren't always round. How do you handle that?
She's exactly correct. At the highest level, if you're talking to a beginner, you tell them to feel the stem, and if it's triangular, then you've got a sedge. When we get into the learning part, matter of fact, in the next 5 minutes, we'll start talking about which genera have triangular stems and which ones have round stems. So this whole thing about simple search, grasses are not simple. All I've done is come up with a simple way to open the door to start to learn about them. And there are a lot of generalities. For instance, we saw that with the rye, where it might have an awn or it might not, that are not, that we'll learn more as we get deeper.
Another question from Nita Winter or Rob Badger is, in the gallery, where does it show native or non-native?
It doesn't. The gallery is a very abbreviated format where there's only 1 picture per plant. But if you look at it in the illustrated list, we have more room where we can use a whole line, and then we'll show native, and in this case, endemic.
Okay. Carla Kelly says, please redefine awns. Are they the seed-bearing portion of the grass?
Thank you for asking that, because I told you everything once, and that's generally not enough to really learn something. So let's go over that. If you picture an oak leaf, it has a vein, and a lot of these veins on oak leaves go out beyond the edge of the leaf into a bristle. Can you picture that, like with a black oak? That's what's happening on a grass spikelet. Two parts of the spikelet, either the glume or the floret, is made up of bracts, and those bracts can have these veins in them that go beyond the edge of the bract, and that forms an awn. So if you think of purple needlegrass, that 3 or 4 inch bristle that's coming out is called an awn. Does that answer the question?
Yeah. Okay. Owen Walker asks, how do I search for a grass in areas that are not listed?
Well, you don't. Well, I'll tell you what you do is you write me an email and you say, here's an area I would like to be able to learn grasses in, and I'll work on it. Let me tell you briefly kind of how this whole thing works from a database point of view. I've entered about 150 grasses. And basically, I'm entering this kind of information about each grass, what its height is. Well, let me change to a more interesting search here. let's go back to bunch grasses. This is the kind of database information I enter about grasses, and I have entered them about 150 grasses. And then I go through my lists, my local lists, and if all the grasses on those local lists are in the table of grasses that I've entered information on, then I can create a local list, as you were seeing in this under grass searches. Now, at this point, I could do more than this dozen lists. I picked out the ones that I thought would be most interesting to the people in Marin and in the San Mateo area, where I'm also working with people on grasses. So I would encourage you to send me a request saying, you know, I like to go over to, I don't know, I'm blanking out now, but yeah, some.
Let's say Potrero Meadow.
Potrero Meadow, and I'll then go look at a list of the grasses there, and if it's easy, I'll just add it to the menu and let you know it's there. And if it's missing a couple grasses, then I'll go define those grasses, and then I'll be able to add Potrero Meadows to the list. But the key to this is this is a really hard problem that we're turning into a really easy problem. And in order to do that, we have to start with a short list, and that's what the local plant list allows us to do.
Another question from Nancy Foster is, what's the difference between INV1, INV2, and INV3?
Very good. Well, they're all invasive, and they're based on Cal IPSI, which is the Invasive Plant Council's ratings. And Cal IPSI gives the grasses that it finds most worrisome, that are causing the most problem as invasives, as a rank of 1. So invasive 1 is the worst situation, and invasive 2 is better, and invasive 3 is still a matter of concern. But that's what the numbers mean.
And Kay Newman asks, can one search by a city or town name or a zip code?
Theoretically, yes, but right now I'm just emerging with this ability to search by a local list. Keep in mind that if you had a zip code, the number of grasses in a zip code is going to be more than the number of grasses on Ring Mountain. So it's not that you couldn't do it theoretically, but the whole purpose of this system is to make the problem easy enough to make it easy for you to get an answer. And I'm doing that by going through local lists. On the other hand, I would love to get feedback from people about additional lists that we should add to it.
Okay. Nita or Rob asks, is there a non-native plant that is like the tall flat sedge?
That's assuming I'm not a database person, but actually a grass person. I'm pretending to be a grass person, but basically I'm just assembling information from a lot of other people. You might ask Doreen or Kristen or somebody who knows a lot about grasses, but I'm not sure if there is a non-native grass that's sedge that's like that. I feel like I can recognize the tall flat sedge really easily, and so I just always assume that's what I'm looking at.
Yeah. Yvonne McHugh says, do you use seeds to ID grasses as well?
I don't, and I would guess that they're hard. Jepson is the sort of, I took back Jepson class and we didn't use seeds. I imagine there are range managers that need to use seeds and examine the seeds, and there'll be databases for that. But grasses have small parts. And so if you're talking about seeds, you're talking about things you probably want to be looking at on a microscope, which means it's not really very convenient for field identification. There's a lot of reasons to not use PlantID. If you're a scientist or if you're a range manager where it's important to get it exactly right, then you use the hard, difficult technical methods. The problem is that for the rest of us, we end up getting left out without any way to do it. So my approach is for the novice enthusiast who just wants to start sitting down with a grass and figure out what it is.
Richard Ackley says, I believe a lot of grasses we see in Marin are non-native, especially from Europe. What are the most common non-natives, and are they easy to identify so that we can then focus on the natives?
Well, the thing that it's certainly easy to identify a dozen weedy grasses in Marin County. The problem is that there's also lots of grasses that are less common that are also still non-native. If somebody, well, I tell you what you could do. Let's see, if we go to do a search. Let's do a search on Ring Mountain grasses, and we could ask, remember we had 56 that were the total list. So I'm going to say non-native grasses on Ring Mountain. How many of those 56? So 21 of those 56 are non-natives. And you could start going through here and trying to learn them, but and that would be an interesting exercise. I mean, you'd find out a lot of these are going to be probably common. I don't have any information about how common grasses are in a specific location, and if anybody would like to tell me how common grasses are in different for these different lists, I would be happy to add searches to PlantID to allow people to focus in on the most common grasses. I was talking to somebody about this as a possibility for Ring Mountain, and she said, well, all I'm going to do is tell you all those weedy grasses that are not really the interesting ones that we want to be looking at. So it depends on your point of view, but it's tricky unless you think about it one list at a time.
Yvonne Hugh asked a question, maybe a little out of your jurisdiction, but anyway, are there non-native bunch grasses in Contra Costa grazed lands like East Bay Regional Parks?
Well, I could answer that question if I had the list for that particular location. She wants to know, remember we saw non-native bunch grasses, a few of them at Ring Mountain. Once we define a local list, wherever it is you're interested in, then you'll be able to do that search.
Yeah. And Nancy Hansen asks, how many grass species are there in Marin County, and could we have a list for the whole county?
You could. I don't think this is a totally successful way to do it, but let me just, if I go into a search and say Marin County grasses, and then say search, I get 280. So I think there are at least 280 grass species in Marin County. And if you organized it as a text list, you could then put it in a spreadsheet, or remember in the demo, you saw how we could create a text list that goes to a report, and then you could print it out. And that would be your list.
Nancy Foster asks, can you create a list for Hamilton Wetlands area, including the adjacent Ammo Hill and Bay Trail?
So the answer is yes. There might be some grasses there that I haven't defined yet that I'd have to go define additional grasses. And I'd be very interested in doing that. It sounded like that description might include more than one, I probably don't have the right word, habitat or kind of area. Ring Mountain is kind of, well, so if your area includes 2 or 3 kind of logical ecosystems, you might want to break it down into 2 or 3 lists. Again, just so you have the advantage of knowing specifically where you are and be working with the smallest possible list of possibilities from there.
Clint Kellner asked,
I would encourage the person who asked that question to send me an email, and I'd like to work with them.
Okay. Clint Kellner asked, did you do this program yourself without help? This is a minimal amount of work. Thanks.
It's been a labor of love for 8 years. I am an excellent programmer. It's what I did in my career, and I was very good at it. And now I'm retired, and I spend half my time fooling with the database program. I love that part. But the answer is absolutely not. I didn't do this all on my own. I couldn't possibly do this without the people that gave me the 130,000 photographs, all the local plant lists. Marin County Native Plant Society has given me 100 local plant lists. And all of the feedback, like for instance, in a meeting like this, people give me ideas and suggestions. This is very much a community project, and I'm providing a really cool ability that I have, but it doesn't go anywhere without information from everybody else.
Christine Jacob asks, can you use CalFlora to search by county?
I believe so. Are we talking about grasses?
I assume so.
Okay, well, PlantID.net uses the CalFlora data. They have given me their database. So I imagine we would get the same answer in CalFlora, but I'm not familiar with the user interface to do that.
Okay. Yvonne McHugh asks, is there a lot of hybridization of either native or non-native grasses?
Good question, and I don't know. Maybe, is there anybody, maybe later on or whatever, people, there are a lot of very good grass people in Marin County that may be in this meeting, and they might have a good answer to that.
Okay, I think we're ready to go on to the next section.
Okay, great. Well, thank you very much for those questions. It made me very happy to hear that you know, I'm catching people's interest and that I'm raising questions. So my next section is the demonstration about learning, which is much more rich than the search, because the search is really pretty simple. So let's go. We were doing grass searches on Ring Mountain, and we were at the sedges when we left off. So we'll say sedge. And we were in the gallery. Well, one of my favorite sedges is the two-tooth sedge, this one over here. And I'll click on it and we'll drill down to the plant page. So anytime you are in a results set and you click on the plant or its plant name, you'll get to the plant page. This sedge has separate spike-like clusters for male and female reproductive parts. So this is a sedge. This one does have a triangular stem. And you can see here, here's the picture of the floral part. The female pistil is protected by a hard green periginium. And then up here in a separate cluster, the male anthers are by themselves and they're naked. They don't have any protection. So what's a periginium? And this is the thing I'm going to keep coming back to about learning. If you're interested in something, click the link. That's how you're going to find out. You can go 3-4 levels deep with information about sedges. Here's an example, periginiums. What's a periginium? So carex, female flowers, and I should mention carex is the most common sedge genus. So carex female flowers have a periginium. That's a hard sac that completely surrounds the pistil, except for a pore at its top, which allows the stigma to stick out so it can receive pollen. If you find this structure, you know you're looking at a carex. Now, I love this plant. These green hard shells remind me of a turtle. And you've got this little pistils sticking out, stigma sticking out. But they're not always green. Periginium on a black alpine sedge, which is also in the carex genus, has a black periginium. But you can see the pattern here, right? You've got these hard covers of protecting the female parts, and the male flowers just kind of loose on top in their own cluster. So reading on about the two-tooth sedge, the fruit develops inside the periginium with the stigma lobes remaining, looking like two teeth, thus the name. Leaves and stems are blue-green, always found near water. Here's another link I'd like to take you on, more about sedges. So we're down to the individual plant. Let's back up a little bit and look at the genus for sedges. Most sedges have triangular edges, and we'll start seeing differences in a minute. That was one of our questions. Sedges are often found in bogs, swamps, or meadows along streams. They generally have long, quite narrow leaves. The inflorescences vary, as you'll see below. And in California, all sedges are wind pollinated. Sedge flowers do not have petals, although when we get to rushes, we'll see that they do. California has 7 genera of sedges. Here's how to distinguish between the major ones. Now, we're not going to spend the whole evening on sedges, but you could spend a lot of time reading through here. First of all, we have carex with these periginiums. Then we have the cypress umbrella sedges, which have this double umbel structure. And I think a lot of you may be familiar with what the tall flat sedge looks like. Here's some more pictures. Then we have another genus called Eleocharis, and the common name is spike rushes, which is a horrible common name because they're not rushes, they're sedges. And these have another structure that is unique, which is tubercles. And so you can, I show you lots of different sedges in this group and how the tubercles work. Then we have the Schonoplectus genus, which is naked stem bulrush and includes two large common California marsh plants, the California bulrush and tule. And we can go on and on about sedges, but I just wanted to let you know that there's a lot of information, including this link to an outside slideshow, which is a college level course on sedges. There's a second layer. I'm going to go up even higher. We started at the plant level, and then we went to the genus. Now I'm going to go up to a key to the different California sedges and rushes. So the carex stem cross sections are triangular. The cypress, that was the tall flat sedge, can be triangular or round. Eleocharis is round, and that's what one of the people was talking about, how sometimes the sedge stem can be round. And the Schonoplectus can be triangular or round and is often ribbed. And you can then go through the leaf characteristics and the inflorescence and so forth. Another fun thing down here is a chart that shows the commonality. So carex is by far the most common sedge. I'm going to back off now and talk about rushes. So we'll go to the plant list and we'll change, in more searches, we'll go from sedges to rushes. And we'll start learning about a rush. I like this gallery view because you can see a lot of different grasses all in one picture. This is all 8 rushes that you will find on Ring Mountain. And I'm going to focus in on the wire rush this time. And it grows in long, unbranched rhizomes. Well, what's a rhizome? Let's say I've forgotten what a rhizome is. Remember that the primary thing for learning in PlantID is to click on links. So if you click on links, you'll get a very nice article, illustrated article about rhizomes and stolons and nodes and shoots and all the things that kind of go together to define a plant and a grass. Flowers cluster at the top of the stem in this is the wire rush with a stem-like bract extending above. So here's the top of the stem, the pale green. And then you have these branches going to very tiny 6-part brown flowers. And then we have this green thing that sticks up beyond, which looks a whole lot like a stem, but is actually a bract, inflorescence bract. Here's a picture you're unlikely to see of in the field of a rush, which is a colorful one showing all the parts. But this close-up shows how rush flowers go together. We've got 6 brown tepals, yellow anthers on short filaments filled with pollen, and beautiful pink stigmas over a superior ovary. So Neil Kramer made this incredible photograph, and I added the arrows in the description, and the combination makes something really cool. So somebody was asking if this is all my work. It's not all my work. I'm the guy that's putting it together. This rush has no leaf blade, just a brown sheath that covers the green stem. Well, what's a sheath? Again, we can go down, and we haven't yet talked about grass leaves, and I won't spend much time on them, but I just want to mention them quickly here. Grass leaves have 3 main parts: a sheath that wraps around the stem, a collar that connects the sheath to the leaf blade and the leaf blade itself. Leaf sheaths may be open with their edges not connecting or closed, forming a complete tube around the stem. Cells at the top of the sheath form a collar. Here's a collar, there's a collar. Often easy to spot because it has different color. The collar has specialized meristem cells. Meristem cells divide, growing a leaf blade above the collar. This means that the blade tip is the oldest part of the blade and its base is the newest. And this is really useful to know about grasses because grasses are often grazed. If an animal comes along and they chew on the leaf, no problem, because the reproductive part is down at the base of the leaf and it can continue to grow out. If the animal, on the other hand, chomps the whole stem and eats the collar area, then that leaf will never grow again. Ligules are, I'm just going to show you that I'm defining it here. That's a whole nother area of interest to people, is looking at ligules. And then you have different shapes of grass blades. They can be folded, they can be enrolled, they can have a canoe tip, and so forth. And then we have what we had on the wire rush, which was that we have the sheaths without a leaf blade at all. So there was a side trip about grass leaves. Remember, we started with we're starting here with a specific grass or rush. Now I'm gonna go down to the general description of rushes. And of course, rushes are similar to sedges, but with some differences, and I list them. Rushes are similar to grasses, but with some differences. Here's that description of these beautiful flowers. And the leaves are evergreen, and they always start from the base of the plant. When we get to true grasses, the leaves can start from nodes on the stem, but for rushes, they always start from the base. And the leaves can be flat or cylindrical, or just reduced to sheaths with no blade. The final two photos show the genus Luzula rather than Juncus. Juncus is the most common rush. The distinguishing feature for Luzula is flat leaf blades with long hairs. So I'm done talking about how you can learn about rushes and sedges, and I'm about to go to true grasses. And there's a lot we can talk about there. But again, Dave, I'm going to check to see if there are any questions at this point.
There are not.
Okay, great. So we'll go back to the home page. Dave Long wrote me an email recently, and he wanted to know more about native grasses in Marin. And so this next section is dedicated to him. I've thought of a search that he could do that will produce a list of grasses that he should look into on Ring Mountain. So we'll say grass search, Ring Mountain. We'll look at bunch grasses that are native. We'll get 18 grasses. These are the ones that, Dave, if you can learn these, you'll feel a lot better, I think, about your ability to recognize native grasses in Marin County. I'm going to start with Calamagrostis of Fididus, serpentine reed grass, which is a rare plant, but is easily found on Ring Mountain. It's got a CNPS rating of 4, which means that it's uncommon in California. And you can see over here on the CalFlora range map that it's very limited distribution in counties north of San Francisco in serpentine areas. It's endemic to California, so it's only found in these little places all around the world. This is the place to go to see this unusual grass. This uncommon bunch grass is found on serpentine rock outcrops. So if you want to learn about serpentine, you can go there and you can go through the glossary article on serpentine. Whoops, didn't want to do that. Two glooms cover a single floret and an awn, which starts at the base of the floret. The floret opens up when ready to send and receive pollen on the wind. Flower clusters start narrow, open up at maturity, and then contract with age. So here we see them opening up. They're going to get a little wider. And then as they get old, they're going to become more dense again. Now, we have a really cool opportunity here, which is to see where Dave will find these grasses on Ring Mountain, because we have an iNaturalist map linked to Ring Mountain for this taxon. So on the Phyllis Ellman Trail, this is a map here of Ring Mountain. If you're coming in from the north on the Phyllis Ellman Trail and you're going up the hill, when you get fairly close to the top, you'll get to this observation of serpentine reedgrass. And I trust this observation because it's by Joey Santour. He's the guy that's crime pays, but botany doesn't, that does those blogs. Anyway, here's some pictures that he took last year on May 15th. And you can see that these, at this point in the middle of May, the inflorescences are nice and open. So here's an example of PlantID taking advantage of information in another system that helps us learn about the plant. So I'd like to go back to the plant list, and this time we'll look at it as a gallery. And we've talked about the serpentine reedgrass. I would also like to show you three other grasses. The California brome is a classic bunch grass. And it's got these beautiful spikelets. Remember, the spikelet has two blooms at the base and then one-to-many florets, sometimes with awns. And that's what we have here. We have two glooms. And then if you count the awns, you see that you have about 10 spikelets in this woven pattern. Very pretty. Here you can see it closer up. So it has long leaves, and the inflorescence gives you this nice classic bunch grass look. Let's go back to our plant list, and I want to show you another grass. The California fescue. And this is one of my favorite drawings by Kristen Jacob, who's been kind enough to donate her drawings as illustrations in PlantID.net. This is a classic California bunch grass with a nodding cluster of spikelets hanging down over graceful arching leaves. The tufted grass has arching, narrow, folded gray-green leaves to 3 feet long. Mature spikelets hang down on long stalks, so it has this kind of drooping appearance. The inflorescence is branched and open. The spikelets contain 4 to 6 florets. Well, when I look at this, I think, gosh, that's pretty close to California brome. So what's the difference? And we'll find out in a minute. The final description here is California fescue is widespread, gracing hills, open forests, and stream banks. And again, just like with the other grasses we've looked at, you can find a reference to the genus and learn more about fescues in general. I forgot to show you that for the California bromes, but there's a similar article for bromes. So let's go to this plant list and compare the California brome and the California fescue. What makes them different? Well, they're both bunch grasses. Their inflorescence length is fairly similar, but the fescue has an awn length of 1/10 of an inch, whereas the California brome can have an awn length up to 6/10 of an inch. So if we go back and we look at the fescue, you can see that there's not much in the way of awns here. But if we go back and look at the brome, there are very noticeable awns. So this is something, I didn't go read this in a book. I simply took the information that was on PlantID and looked at the table and was able to figure out the difference between these grasses, which will be very helpful for me when I'm in the field, because both of these show a lot of florets and kind of look similar. The last grass I want to show you is maybe my favorite, and that's the California melic. This is a grass that I didn't have much of a sense of before I took the grass class last December and started this project. California melic is an erect plant with ascending flat leaves. Spikelets look like close to the stem. So this is different than those other ones which were branched and loose. These are branched but have tight clinging to the stem, making a narrow cylinder. The melica spikelets are oval and cylindrical, not flattened like most other grasses. So if you look over here at this picture, this spikelet looks different than the spikelets we've been seeing before. They're kind of roundish, they don't have awns, and they have papery glooms. The papery glooms turn purple, although several grasses turn purple later in the season. But if just look at this, you get the feeling that's what a melica looks like. So let's talk about melicas a little bit more. Melica is the only California genus in the melic tribe. So this is a new concept, grass tribes. We're going to talk about that in a minute. California melica grasses have distinctive characters. They're always native and they're always perennial bunch grasses. Melics have no awns except for the awned melic. Spikelets are cylindrical and not flattened. Glooms and florets have a rounded back, not keeled. These glooms and florets have round tips that are not pointed. And the gloom and floret edges are papery and translucent. Let's go look at the melic tribe. So now we're going up one more layer. Instead of talking about genera, we're now talking about tribes, which include lots of genera. And we have a key here. So for instance, we were talking about melics that had short papery florets were visible, short papery glooms with visible florets. The two kinds of tribes I want to talk about here are oats and wheats, because we really haven't talked about those yet. What's the difference between an oat and a wheat? Well, let's start at the summary key level. The oat has an inflorescence that's branched. The glooms are long and papery. A wheat does not have, it has a spike-like inflorescence with short glooms, and the spikelets are in two ranks. So if I go down to oat, I get these beautiful drawings by Lynn Clark from the Agnes Chase First Book of Grasses. And anybody who wants to find a book about grasses that help you learn, this was my first and my favorite book about grasses, Agnes Chase's First Book of Grasses. And in this diagram, Lynn shows the branched inflorescence for the oat tribe and very long glooms, think wild oats. Inside, you can have one-to-many florets, and notice that these awns are odd. Instead of the awns coming off the tip of the floret, they're coming off well down. So this is like a vein goes up the bract, and then instead of continuing on to the tip, it just comes right off in the middle of the bract and forms an awn. Let's look at wheats. Wheats are going to have a spiked like inflorescence with short glooms instead of the long glooms of the oats. So here we have spikelets in two ranks. These spikelets actually dig into the stem. So you can see the notched stem. So sometimes as you go along and you look at a grass and you look at the stem and it has notches in it, that's probably a wheat that you're looking at. And there are a bunch of genera that are members of the wheat tribe, like Elamis and Hortium. Let's go back up to the oats for a minute. The members of the oat tribe are the bent grass, hair grass, oats, reed grass, velvet grass, canary grass, and so forth. So these tribes are conglomerations of a large number of genuses, and they're a useful way to think about grasses. So you can start thinking about grasses one species at a time, and you can also think about it at the genus level or at the tribe level. So I've shown you many examples of how you can learn about grasses in PlantID, and I've tried to make PlantID a great place to learn about grasses. My advice to you is just follow links and dive in wherever you want. Come back many times, sometimes focusing on a single plant, other times on a genera or tribe. The more exposure you get, the better you'll understand grasses. So let's review what we did in the demo. The search, we picked a location, we entered search criteria, and we compared results. Once you've identified a grass or group of grasses, you click links to learn more about them. The plant page shows you photos and captions that describe a grass. It offers quite a few links to outside resources. I've been actively learning about grasses for the last half year and have written quite a few illustrated articles to help me and you learn about them. I've shown you articles on grass parts, sedges, rushes, grass genera, and tribes. I've also given you links to good sources for more reading. So this is my concluding slide. I've met many people who've said something like, I've tried to learn grasses, I've taken classes and bought books, but it's too hard. Last December, I took a Jepson class with Travis Columbus of UC, and he helped me design this simplified approach to grasses. I also worked with Al Fengler at Edgewood Preserve, and between them, they helped me design and build a different approach to grasses designed for novices. You don't need to study dense texts and learn lots of terminology in order to have fun with grasses. Use PlantID's local grass searches to focus on small groups of grasses, and then use PlantID to find lots of descriptive and comparative information to get to know them. Have fun with it. So Dave, that's the end of my presentation.
Okay, we have a few questions in the chat, and then I'll open it up to any live questions that people want to ask. Anita Winter or Rob Badger asked, you know, which of these 4 categories of grass and grass-like plants evolved first?
No, I'm trying to think how you would find that out. Again, there are great experts, grass experts in Marin County that should be addressing that question, but I don't think I'm qualified.
Okay, Don Davey asks, will the scientific names be kept updated to reflect the latest understanding? I see Stipa instead of Nacella, or am I out of date and it shifted back?
Well, this is a problem for everybody, keeping up to date. Luckily, it's not my problem. CalFlora pulls together changes made by Jepson, but also by other organizations and also by other stakeholders outside of Jepson. For instance, range managers use CalFlora, and so they include additional genera to support that. And the Native Plant Society itself asks CalFlora to put things together. I use the CalFlora taxonomy. So once a year, I update my taxonomy to match what they've done. And John Malpas at CalFlora is really good at thinking about kind of keeping up to date on the taxonomy, and I just ride on his coattails.
Okay. Barbara McCord asked, where do the articles come from?
Well, a lot of the ones I just showed you, I wrote. I have some advantages. First of all, I'm a beginner, and so I know what a lot of the beginner questions are. I've got fabulous library of photos to work with. And so what I do is I get interested in a question. For instance, well, I want to learn about bromes, and I'll go read about that in a lot of different sources, including this Agnes Chase book on grasses. And then I'll pick out what seems important to me, and I'll find pictures that illustrate it. For instance, the periginiums I'd never heard of on the carex. But once I saw it, I said, boy, that's a great story. I want to write about it.
Betsy Crawford asks, are blooms only at the base of the inflorescence, or does each floret have blooms?
Well, I'm really glad she asked that question. So let me review. The inflorescence is everything above the leaves when you're talking about a grass. So everything that sticks out beyond where the leaves are coming out is the inflorescence. And basically, that is where all the spikelets are. The spikelets may be attached in a variety of ways. Each spikelet is made up of 2 glooms. There's some minor exceptions, but basically you can just assume it's 2 glooms and then 1 to many florets. And so if you think about a sunflower flower head, you've got filaries underneath the different flowers, the ray flowers and the disc flowers. So the filaries are equivalent to those blooms. It's the basic protection that the rest of the floral part sits in. And then inside the glooms, you have florets. And I have not at all, I've very intentionally not talked about all the different parts that are going on inside a floret because you don't really see them. What you see is a bract that covers a lot of other parts. And that bract is called a lemma. Inside the lemma is a palea, and inside the palea are the male and female parts. But you're not seeing that most of the time when you're out in the field, so I've ignored that. So just to answer her question, the glooms are at the base of a spikelet, and the florets are stacked up inside the glooms, and together the glooms and the florets make a spikelet.
Yvonne McHugh asks, are there any extirpated grasses folks should be looking for?
Well, that's a great question too. I hope that these questions don't get answered because I don't know the answer. These are a lot of good questions I'd like to find out the answers to. I don't know that one.
Okay. I think that's the last question in the chat. If anybody wants to ask a live question, I'd encourage you to use the raise hand feature, which is in reactions. On a computer, it's at the bottom. And because there are too many people, I can't see folks. So just, if you would use the reaction raise hand, if you want to ask a question, if there are no questions at this point. We're about at 10 till 9, and it looks like there aren't any additional questions. Oh, Lynn Barron, do you have a question? You can unmute yourself if you do. You have, I see you have your hand up.
Yeah. That was
you're
a
unmuted.
mistake. That was a mistake. I was
right.
clicking on the wrong thing. Sorry.
Okay. Well, I don't see any questions. So, Bruce, that is a phenomenal database you have, and it's just, you know, I'm just flabbergasted at how much work has gone into that, and how useful it is. I mean, it's just spectacular. So thank you so much for
Betsy Bickle has her hand up.
Oh, okay.
Thank you very much. Bickley is how you pronounce it.
Sorry.
I have a particular interest in carex pendula. And so is there a way to look on there and see how widespread it is, let's say across Marin or other parts of California?
Yes. I'll go back to sharing the screen briefly.
Thank you.
Mm-hmm. Okay, and I'll get out of this. So I think you're now looking at, so if we say carex, and what was the pendula? Can you hear me okay?
Yeah.
Okay, was it, oh, here it is, hanging sedge, carex pendula. So if we go to the plant page for carex pendula, this CalFlora gives a range map that shows where it appears in California. This is a very interesting plant, isn't it? Because it doesn't appear in a lot of different places. There's a high risk of this plant becoming invasive in California, according to Calypsy. That's interesting. So I think probably what you're looking for is something a little finer tuned than that.
Probably has to unmute herself.
Yeah. Although it looks like from the map, there are only 3
Yes.
places where it's been found in Marin.
Yep.
Uh-huh. All over Mill Valley.
What you can do is go into CalFlora and look at these options, and it will tell you where they are.
Okay. Please,
So,
if he sees it, pull it out.
excuse me?
Please, if anybody sees it, pull it out.
Yeah.
5-year lifetime goal.
I appreciate you telling me that. I'm gonna go find out what it looks like, so I'll know what I'm looking for.
Good. Yeah, I have a little pamphlet on pulling it out. I'd be happy to send to you.
I appreciate it. My email, by the way, I should have said this before, and it's plastered all over the website. It's bruce@plantid.net.
Okay.
And please correspond with me, everybody. I get off on hearing what people are doing with this and any contributions they want to make to the material that's in the site. That's what makes it good.
Bruce, this is Nita Winter, and I just really am so impressed with what you've done over the years, because I remember when you first started it.
Yes.
And this is just awesome. And Rob and I have been giving talks all over the state for our book, Beauty and the Beast. And people ask, how do we identify plants? And this is one of the sites that we refer to people to, especially if they're novices. And now I know more about it, and I will encourage them we'll do a link to the video. Are there other videos that we might want to put on our site that are sort of training videos?
I'd like to work with you on what you'd recommend. I think the introductory video that I showed at the beginning of this was very useful. And it might be, now that I have kind of polished up the grass approach, I ought to turn that part into a video. This whole thing, it's really a question of what people are interested in. That's where I pursue it. I've been doing this for 8 years, going in various directions, depending on, what interesting things people got me started on.
Well, very impressive. Thank you.
Yeah.
Thank you.
Thanks so much, Bruce. This has been great.
You bet.
And before we leave, I'd like to tell you about next month's program. It's going to feature Peter Bay, who's a well-known wetland biologist, talking about the impact of sea level rise on native wetland vegetation and mitigation strategies. This is an issue which has come to the fore with one TAM featuring mitigation options for both in marsh in Mill Valley, kind of as the test case for what we're going to do about sea level rise, which is serious because we have these marshes right up against developed areas, and there are limits to how far it can go before the marsh just goes away. And the question is, what is the end game, and what is the process for getting native plants and rare vegetation migrating as sea levels rise? And I think Peter will have some important things to say about that. So that's July 12th, the second Monday of next month, and we hope you'll attend. Again, thank you for being with us tonight, and hope to see you next week, or next month.
Thank you.